Okay, the first question on our Chapter 9 practice test is finding the least positive angle that is coterminal with negative 90 degrees. So we want to remember that coterminal means that it's going to lie on the same angle in the unit circle. So what that means is you're going to be going around the unit circle one full time. So we'll be adding, since it's positive, you're going to add 360 degrees. So we're going to take negative 90 degrees and go around one full circle. So 360 degrees. And these are different signs, so we're going to subtract them and keep the sign from the larger number. So we end up with positive 270 degrees. Number 2, we're going to find the values of sine, cosine, and tangent for angle theta when AC equals 100 and BC equals 80. So I'm going to go ahead and write that in. Sorry, my triangle looks like this. My printer at home did something weird to that hypotenuse. Okay, so AC is 100, BC is 80. And then if we want to find sine, cosine, and tangent, we need to find this adjacent side. So I'm going to put an X, and then I'm going to use the Pythagorean theorem to solve for that missing side. So a squared plus b squared equals c squared is that formula that will help us solve for x. What we do want to remember in this formula is that your hypotenuse is always going to be the c that you plug in, and your a and b are the legs, so those are interchangeable for a and b, but definitely hypotenuse always gets plugged in for c. So when I plug in x squared plus 80 squared equals 100 squared, so that's x squared plus 80 squared, that's 80 times 80. So what you could do with a shortcut is for 80 times 80, just do 8 times 8, that's 64, and then tag on 2 zeros. Since with 1 0, when you square it, it'll give you the 2. And then 100 squared, just do 1 squared, which is 1, and then 2 zeros, but when you square, it'll double the 0, so a total of 4 zeros. So 100 squared gives us 10,000, and then we have to solve for x, so we're going to subtract 6,400, and then 0 minus 0 is 0, 0, this becomes a 10 and a 9, so we get 3,600, and to get x by itself, we're going to do the square root. So x is equal to the square root of 3,600. So what's the square root of 36? That's 0. Or I'm sorry, square root of 36 is 6. And then think of this as like the square root of 100. It's 10, so it gives you 1 0. So the square root of 3,600 is 60. And don't mind my little rules if those didn't make any sense to you, because I believe on the exam the numbers are going to be a little bit a little bit smaller. So that'll help you out a bit on the exam. Smaller numbers, so don't worry too much. Okay, so now if this is theta, we have to understand that when we find sine, cosine, and tangent, these side lengths have some labels that absolutely matter. So I'm going to write those in for you guys. We always across from that reference angle, or that theta, is called the opposite leg or opposite side. And then right here, this is our adjacent. So 60 is that length of the adjacent side of the triangle. And then longest side is always your hypotenuse, or across from the right angle is always hypotenuse. So now that we have that labeled with all 3 of the sides, we can list sine, cosine, and tangent. So sine, we remember, I'll write SOHCAHTOA over here for you guys. SOHCAHTOA. Sine means opposite over hypotenuse. So you take, here's theta over here, opposite goes on the numerator, and then hypotenuse, which is here, goes on the denominator. So it's 80 over 100 for sine, but we do want to simplify. If we divide out 10 top and bottom, 1 0 cancels, 1 0 cancels. We get 8 over 10. Continuing to simplify, divide 2 top and bottom, we get 4/5. So sine is 4 over 5. All right, let's keep going. Cosine. And we use SOHCAHTOA to help us remember cosine is adjacent over hypotenuse. So it's adjacent 60 over hypotenuse 100. Again, divide out 10, top and bottom, and that cancels out as 0. We get 6 over 10. Then if we divide 2, top and bottom, we get 3/5. So our cosine is 3/5. Last one, tangent. Again, looking at our shortcut SOHCAHTOA, or a little hint that we left ourselves, tangent means opposite over adjacent. So opposite is 80 and adjacent is 60. And divide 10 top and bottom, we get 8 over 6. And then you can simplify, reduce further, you get 4/3. So 4/5 for sine, 3/5 for cosine, and 4/3 for tangent. So it looks like our answer is B. Number 3, we're going to write this expression in simplest form. So what we want to do right here is we want to get rid of the radical, or the square root 10. So what we're going to do is we're going to multiply by our 8 minus square root 10. So what you do is you're going to take the sign, excuse me, and change it. So it's a positive. So now I'm going to make this a negative. So you change the sign in front of the radical, and that is what you're going to multiply top and bottom. So 1 times 8 will give us 8. And 1 times negative square root 10 is negative square root 10. For the bottom here, 8 times 8 is 64. 8, well, because I'm foiling or distributing here. So it's 8 times negative square root 10, which is negative 8 square root 10. Then positive square root 10 times 8 is plus 8 square root 10. And then positive square root of 10 times negative square root of 10 is negative square root of 100. Remember, when these are both underneath the square root, you can multiply them. You just need to leave it under the square root, that answer. So 8 minus square root 10 is going to stay on the top of our fraction. That's not going to simplify. Then down here on the bottom, it's going to be 64. Negative 8 square root 10 and positive 8 square root 10 are going to cancel each other out. And then this is going to be the square root of 100, which is 10. And I just copied down that minus sign. So we get 8 minus square root 10 over 54. So it looks like our answer is D. Okay, number 4. Which is the first incorrect step in simplifying log base 4 of 4 times 16? So in step 1, it looks like they rewrote this as log base 4 of 4 plus log base 4 of 16, and so far this looks good because we remember when we are expanding, the multiplication expands as long as you use log base 4 with each of these numbers, which they did, and you use a plus sign to add. Okay, and then it looks like they simplified. So log base 4 of 4 is 1 because 4 to the power of 1 is 4. So that number's correct. Then they simplified log base 4 of 16 and said it was 2, which is also correct because 4 to the second power equals 16. So that looks good. And then 1 plus 2 is 3. So each of these steps is correct. Okay, in number 5, we are going to be solving. I'm going to go ahead and rewrite this. That way I can do my work underneath it. Okay, so we're trying to get x by itself. So first thing I'm going to do is I'm going to subtract 7 to both sides, and that's going to give me 2 times x to the 1/2 power is equal to 20. And then I need to divide away the 2 out in front, and I get x to the 1/2 power is equal to 10. So now I'm almost done. I just need to get rid of the 1/2 power. Anytime we want to get rid of an exponent that is a fraction, you are just going to raise both sides to the reciprocal of that fraction. So it's going to be 2 over 1 raised to both sides. So this is going to cancel out, and we're just going to get x equals, and then we get 10 to the 2 over 1 power, but let's just make sure we understand that just means 10 squared because 2 over 1 is 2. And then 10 squared gives us 100. So our answer is just positive 100, D. Okay, number 6, we're looking for the period of the trig function. So that's going to be how long it takes to go through one full period. So I know that this is our cosine function because it's not passing through the origin. That would be the sine function. So we can start here. It's going to pass and come back up here, and that's going to be one full period for our cosine function. So it's going to end right here at, or not end, but the period ends here at 2 pi over 3. So our answer is D. Okay, so number 7, we're going to simplify. Since these two numbers are both underneath the cube root, we can multiply them as long as whatever answer we get stays underneath the cube root. So I'm going to go ahead and multiply 108 times 2, and I get 216. So it's the cube root of 216. And then if we want to simplify that, it's going to be what number times itself again gives you 216, and that's 6. Because 6 times 6 is 36, times 6 is 216. So my answer is 6. Okay, number 8, let me make sure we can all read this really quick. I forgot to add in this one. It looks like this should be a P, a Q, an R, P, and a Q, and a lowercase r. Okay, so they're telling us, or this is triangle, they probably meant to say PQR. Angle PQR is 90 degrees, and that they already give us. That's right here where they show that 90-degree symbol. So that angle is 90 degrees. Angle QRP, which is this one here, is 65 degrees. That's what this means. And they want to know the measurement of angle QPR. So QPR is this angle here. And if we want to find that missing angle, there are ways we can do it using like sine and cosine or tangent or trig functions, but we have an easier way to do this. You just need to remember the triangle sum theorem. So the triangle sum theorem from geometry says that the angles in a triangle have to add up to 180 degrees. So since we know this one's 90 degrees and this is 65, we can find this if you just create an equation. So it's going to be 90 degrees plus 65 degrees plus x will equal 180 degrees. So we're going to add 90 plus 65. So combining like terms, this is what we're going to have. And then solving for x, we get x is equal to 25 degrees. Okay, number 9, an 11-foot ladder is leaning against a wall. So that's what they're showing here. The ladder makes a 54-degree angle with the wall. Which is the closest distance up the wall the ladder reaches? So this question mark, I'm going to put an X right there. That is what they are asking us to find the length of. This side of the triangle formed with the ladder and the wall. So what we want to understand is that we're going to use 54 degrees as an angle to create a trig function to solve for the missing side. So if this is our angle, then we have to understand the relationship with these sides. This X here would be the adjacent side, and 11 is across from this 90-degree angle, or the longest side in the right triangle. And since we don't have an opposite, okay, we're gonna focus on having the adjacent and hypotenuse as some sides we're gonna use to solve. So that means, we remember SOHCAHTOA, we want to use the cosine function because we have adjacent and hypotenuse, okay? So we're gonna be using the cosine function, and I can write that up here just so everyone remembers. Cosine of theta is equal to adjacent over hypotenuse. So what I'm gonna do is I'm gonna set that up. I'm gonna have cosine of 54 degrees is equal to adjacent over hypotenuse. The adjacent is X and the hypotenuse is 11. Okay, so that's how we're gonna set up. and then we're gonna solve. So if I wanna solve, all I do is make this cosine 54 a fraction by putting a 1 underneath, and then we're gonna cross multiply. So it's gonna be 1 times x is x, copy the equal sign, and then cross multiply here. It's 11 times cosine 54 degrees. So we are not able to use a calculator. So what I'm gonna do is look up here in this box. They tell me cosine 54 is about 0.59. So I'm going to use 0.59 and plug that in for cosine 54 because I know cosine 54 is about 0.59. So I'm gonna be multiplying 0.59 times 11. I'm gonna do that down here. And that is gonna be my answer for x when I multiply. So 1 times 9 is 9, 1 times 5 is 5, 1 times 0 is 0, placeholder, 9, 1 times 5 is 5, 1 times 0 is 0. I'm gonna add down and I get this, but there's 2 decimal places here with the numbers I'm multiplying. So in my answer, I have to have 2 decimal places. So that adjacent wall is gonna be about 6.49. Number 10 is going to take us back a couple of chapters when we had our rational, our rational functions. So what we have is some fractions that we need to simplify. So remember the procedure is to factor each one of these numerators and denominators, and then we're going to be canceling out their common factors. So x plus 4, I'm just going to go ahead and rewrite. I'm going to rewrite it down here. I'm going to rewrite both of these fractions after I factor. Okay, so x plus 4, we can't factor at all, so I'm just leaving that. X squared plus 6x, I'm going to show the work for factoring that down here. I'm going to, since I have 2 terms, I'm going to factor using GCF, so I'm going to divide out x from each of those terms. So you take that common factor, write it, open parentheses, and x squared divided by x is x, 6x divided by x is 6. So if I were you, I would just go ahead and distribute, just check your work, x times x is x squared, x times 6 is 6x. So x times x plus 6 is how you're gonna factor the bottom of this fraction here. Okay. I'm going to copy that multiplication symbol, and then I'm going to look at my next fraction, x cubed minus 36x. I'm going to show the work for factoring that down here. Again, 2 terms. I'm going to factor out the GCF, and that's going to leave me with x cubed divided by x is x squared. Negative 6x divided by x is negative 6. And then, oh my goodness, I wrote 6 and it should be 36. Sorry guys, quick fix. It's minus 36x. So when I took out x, I just have negative 36. And then I'm going to distribute that back to check my work. X cubed minus 36x. Okay, good. But I'm actually not done factoring this. This here is the difference of 2 perfect squares. So I'm going to use the formula a plus b, a minus b. And when I factor x squared minus 36, it's x plus 6 and x minus 6 because of that formula. This one right here uses a plus b and a minus b. So that is how I factored, and I'm gonna write that up here. It was x times x plus 6 and times x minus 6. Okay, last part that we need to factor is x squared minus 2x minus 24. So I'm going to take that trinomial and I'm going to write it down at the bottom. X squared minus 2x minus 24, and I'm going to factor x times x equals x squared. 6 times 4 will get me to 24. And I want to add up to negative 2x, so x times 6 is 6x, x times 4 is 4x. So in order to add up to get to negative 2, the negative needs to go with the 6, positive 4. Carry over the negative, carry over the positive. So to factor this trinomial, I get x minus 6 and x plus 4. So I'm going to write that here. And this is how I would factor both of those fractions completely. So now I'm going to start canceling. So if I were to multiply these across, which I guess I could do for you guys. Let me just get a different sheet of paper. If you were to multiply all of this across, it would be x times x plus 4 times x plus 6 times x minus 6. So that's just across the top, and I added in some parentheses around this. So across the top, this is what I would have, and then across the bottom, if I multiplied everything across, this is what I would have. And then I would cancel out same factors top and bottom. So the x's cancel, x plus 6, x plus 4, and x minus 6. So if everything cancels, a lot of people like to say the answer is 0, but the answer is not 0. Your answer is 1. Okay. Okay, and number 11, we're gonna write this expression in the simplest form. So what I'm gonna do is I'm gonna cube, since we're doing the cube root to all of this, I'm gonna separate our negative 27, the x, the y, and the z. So I'm gonna take the cube root of each of those individually. So I have the cube root of negative 27 times the cube root of x to the 5th power times the cube root of y to the 12th power times the cube root of z to the 8th power. So what I'm gonna do is use the cube root of negative 27, which we should know what number times itself again gives us negative 27. That's gonna be a negative 3. Okay, then I have that simplified, so done with that one. Here is the cube root of x to the 5th power. So this is asking us how many x to the 3rd power can we take out of this? If it's x to the 5th power, we can only take out one x cubed. So I'm taking out an x cubed and doing the cube root of it, and I get x. So that's gonna leave me with 2 x's left inside. So it's x squared inside. All right, then I'm gonna look over at y to the 12th power. The cube root of that is how many y cubes can we take out of this, or divide 12 divided by 3, and we get 4. So y to the 4th power, and there's no y's left under the square root. Okay, so moving on to this one, we're looking for how many z cubes are in 8, or really, if you want to do that dividing thing, how many times can you divide 8 by 3? That's going to be twice. So we can take out y squared, but that would leave us with 6. So, or that would leave us with 2, because 8 minus 6 is, why did I write y? I wanted to write z. Sorry, guys. We took out a z squared because there's 2 z cubes. And then if we took out 6, that would leave z squared inside. So, sorry, that got sloppy. I have negative 3x, y to the 4th power, and z squared that we were able to take out. And then what's left underneath the square root is the x squared and the z squared. So let me write the cube root. So they use parentheses, let's use parentheses. And then the cube root of x squared z squared. So I actually don't see the answer here. So it looks like maybe there's a mistake on the multiple choice. So we're gonna go with that, and hopefully Miss Homestead isn't messing this one up, which I don't think I am, even though it looks real sloppy. All right, so moving on, number 12. We're gonna determine whether the inverse of f is a function, and then find the inverse. So we need to know that to determine whether the inverse is a function, you're gonna do the horizontal line test. So this horizontal line test, what you're gonna do is you're gonna draw a graph of the function. So here's my function, square root of x plus 9. So here, let's just do a quick sketch of this. So the square root graph, we know, let me draw a quick function, parent function. That would be the square root of x if I drew a graph. Okay, so square root of x plus 9 just means shift that parent function to the left 9. So to the left 9, somewhere over here, and then there's my square root function. So that's how I would graph this. what you're gonna do to figure out whether this is a function, whether the inverse of this is a function, is our horizontal line test. So the horizontal line test says, if you draw a horizontal line and it crosses the graph more than once, then it fails. So since I drew a horizontal line and it only touched my graph once, so far so good. If you draw infinite horizontal lines and each one only hits the graph once, then it's gonna pass the horizontal line test. So if I were to draw like infinite of these horizontal lines, each one of them would only cross my graph one time. So that means it is a function. Yes, it passes the test. So yes, the inverse is a function. So I'm gonna go ahead and eliminate B and D because we know the inverse is a function. And then after that, let's find the inverse. So here it is. I'm going to use y instead of f of x. And to find the inverse of a function, you switch x and y. And then we're going to solve for y. So to get rid of the square root, we're going to square both sides. And I get x squared is equal to the square root and the square are going to cancel out. We're going to get y plus 9. So to get y by itself, subtract 9. You get x squared minus 9 equals y. So your inverse is x squared minus 9. So my answer is A. We're looking for the angle that is going to be drawn at negative 340 degrees in standard position. So remember, the negative is going to have us go the opposite direction in the unit circle. It's going to have us go down or clockwise. So this right here, an A, is not going down. It's going positive in the positive direction. It can't be A. Again, this is the positive direction. For B, it's going up. That's not correct. And then when you get to C, C is our answer because it is going around the circle in the negative direction. And let me remind you that this would be negative 90 degrees. Then this would be negative 180 degrees. And up here is negative 270 degrees. And then around the circle would be negative 360. So negative 340 is going to lie between negative 270 and negative 360. So your answer is C. And then it can't be D. D does go in the negative direction, but it goes too many times around the circle. 340 is less than one full time around that unit circle. Okay, number 14 is again going to take us back a couple chapters ago. What we want to do first is rewrite this. I'm going to leave my first fraction because when you are dividing fractions, you're multiplying by the reciprocal. So what we're going to do is we're going to change that division to multiplication, and we're going to take the reciprocal of the second fraction. So 30y to the 9th power will go on top, and then 21x to the negative 3rd is now on the denominator. So what we're going to do is we're going to be multiplying across this fraction and multiplying across top and bottom. So these numbers are going to get kind of big for us. So what I want to do first is we can actually divide out 3 top and bottom from this one just to make our numbers a little bit smaller. So if I divide 3 here and here, 30 would become 10, and then 21 would become 7. That way when I start multiplying and dividing, the numbers are a little bit smaller. Okay, so when I multiply across, I'm going to look at my coefficients. 14 times 10 is 140. And then x to the negative 6 and y to the 9th power, because those are different variables. You leave their exponents. All right, then it's going to be 15 times 7, so I can show that work. Here, I get 105 as the coefficient, and then x to the negative 3rd and y to the negative 4th. Those I'm just writing. I'm not going to combine those at all. You just multiply them. Different variables, don't do anything with their exponents. So 140 and 105, what I'm going to have to do is simplify that even more. So I'm going to divide out numbers top and bottom. So it should be very clear to everyone that you can divide out, let's say 5 from top and bottom. So 140 divided by 5, I can do that work up here. 14, 5 goes into 14 twice. Subtract, bring down, I get 28. So 140 divided by 5, my new coefficient will be 28. And then on the bottom here, 105 divided by 5 is 21. So I get 28 over 21. And then let me just write down these where I have some more room. It was kind of crunched over there on the edge of the paper. So I'm just rewriting all the rest of that. So all I did on that part was try to simplify my fraction, or reduce the 140 over 105, dividing 5 top and bottom. So I am actually going to simplify that fraction some more. I'm gonna divide out 28 and 21, we can divide out a 7, top and bottom. When I do that, I get 4/3 as my coefficient. So 4/3, and then x to the -6 and x to the -3. The rule is you can't have negative exponents, so x to the 6 is gonna move to the bottom, and x cubed goes to the top, because when you move your negative exponent, it becomes positive. So -6 when it came to the bottom became +6, and the -3 became +3. So my rule now with my x's, if there's one on top and one on the bottom, you are going to be subtracting. Because we're dividing these, you subtract. So it's going to be x to the 3 minus 6 power, which gives us x to the -3rd. So since that is a negative exponent, we have to put it down here at the bottom. And it's x to the +3rd power. All right. And then we are lastly going to look at our y's. So let me cross these out. We already took care of those. The -4 we can't have. We're going to move it to the top. And y to the 9th power and y to the 4th power, we are going to multiply. So you keep the y and add the exponents. 9 plus 4 is 13. So our answer is D. Okay, number 15, we're going to find the reference angle of 235 degrees. So remember here, we're starting at 0 degrees, 90, 180 is here, and 270 degrees is here. So 235 is going to lie over here in the 3rd quadrant. And remember, every time you're creating your reference angle, it's always with the x-axis. So what you do is you're going to subtract with 180 degrees. And that is going to give me a 55-degree reference angle formed. Number 16, we're going to let G be a reflection in the x-axis, followed by a translation 1 unit up of this following function. So we remember a reflection in the x-axis is going to make our function a negative, so it becomes -4 out in front. And then if I translate 1 unit up, what it's going to do is it's going to add 1 to the outside. So our answer is A. So just keep in mind that underneath the radical, when you're reflecting in the x-axis, stays. So don't pick D, it would be A. Only the -4 out in front. The rest of the signs stay the same, and then up 1 gets a +1 as your K value on the outside. Okay, number 17, we're looking for angle A, where sine of A is greater than cosine of A. And we're going to select all the angle measures that are possible for angle A. So we're looking for, out of these 5, where is sine of that angle going to be greater than cosine of that angle? So after contemplating, I'm going to show you guys where each of these angles are, and then we're going to do each one individually. So we're going to need some probably extra room at the bottom of our paper. I'm going to look at 120 degrees. So for part A, I'm going to draw that right here for you guys. 120 degrees, if this is 90, this is 180. 120 is going to be about right here. And if I draw the triangle, it's going to form with my 180 degrees at my x-axis, a 60-degree angle here is my reference angle. So this is going to be a 30, 60, 90. All right, so if I want to look at the sine versus cosine, I'm looking at sine of 60 degrees versus cosine of the 60 degrees. So I'm looking at this as my sine versus the cosine. So I know always across from the 60-degree angle is going to be square root of 3, and across from the 30-degree angle is always 1. But since I'm on my x-axis, it's a negative. So in this case, the sine is greater than the cosine, because sine, which is square root of 3 over 2, is going to be a positive number versus a negative number for cosine. So 120 degrees is where, first of all, we have our sine greater than cosine. So that's going to be our first answer. And then let's look at 150 degrees. So 150 degrees, if I were to plot that, this is 180, 150 would be about right here between 90 and 180. So this is a 30-degree reference angle. So again, we're going to look at the sine here versus the cosine. So across from 30 degrees is 1, and then our cosine across from 60 is going to be our negative square root 3, because we're in the second quadrant, the cosine's always negative. So again, my answer, 150 degrees, it is one of my answers, because sine is a positive 1/2, and then the cosine is going to be a negative square root 3 over 2. So I know that since sine is positive and cosine is negative, that sine is greater than cosine. So B would be my next answer. So let's look at 330 degrees. If you were to plot 330 degrees, it would be, if this is 270 and 360, then 330 is right here, and that is going to be my 30-degree reference angle. So in the fourth quadrant, we can compare sine and cosine. The sine is always going to be over here, and then cosine will be here. So the sine of the 30-degree angle is going to be a negative number, so it'll be negative 1/2. And then your cosine of the 30-degree angle, or across from the 60-degree, is going to be a positive square root 3. So in this case, sine is smaller than our cosine, and that's not what we want. We want where sine is greater than cosine. So my answer cannot be 330 degrees. Okay, 45 degrees is going to be, if this is 0, this is 90, it's going to be right here between 0 and 90 degrees. So we know in the 45, 45, 90 triangle that's formed here, each of these legs are 1, because sine of 45 is 1 over square root 2, and then across from the 45-degree angle here is also positive. So these legs are going to be the same length, which means sine of A and cosine of A are equal. So that is not where sine is greater than cosine, so 45 degrees is not my answer. And then last one, E, 60 degrees. If I were to put that 60-degree angle, it would be here, and then this forms a 60-degree reference angle. So we're looking at sine of 60 degrees versus cosine of 60 degrees. So we know across from 60 is square root 3, and then across from 30 is 1. And this square root 3 is 1 point something. It's a number greater than 1, and this is only 1. And so we do have sine is greater than the cosine. And also, look at where you're drawing your triangle. This side length does look greater than this, because the across from 60 is always going to be a bigger side than across from the 30. So this is, again, another answer that we want, because sine of A is going to be greater than the cosine. So my answer is also 60 degrees. In number 18, we're choosing the functions that represent exponential growth. So remember, an exponential growth, it's when your base is greater than 1. So we're looking for numbers that are greater than 1 that would represent our exponential growth. So 8 is greater than 1. So that's exponential growth. 1/7 is less than 1. 7's greater than 1, and 1/8 is less than 1. So my answers are A and C. Okay, number 19 is going to move on to the open-ended. So if you have a Miss Ting or Miss Dixon, I know that they teach this a bit different. So just maybe move on to Miss Ting's video now if you have them as their teacher, as your teacher. Okay, so we're finding the missing links. This is our 30, 60, 90 triangle. I think this 30 degrees should be in this angle, just to make sure that's what you guys are understanding. It's just over to the side a little bit. Okay, so this is our 30, 60, 90. We know if this is 30 and this is 90, then this has to be a 60-degree angle. So what we want to be careful is this is not drawn to scale. So we have to remember that across from the 30-degree angle is where you're going to get your rules. So that's supposed to be the shortest side if this were drawn to scale. And then you have your rules from this side. Since I can't draw them in this little triangle, I'm going to draw them over here to the side. Your rule from this shorter side to the hypotenuse is to multiply by 2. And your rule from your shorter side to get to the longer leg is to multiply by square root 3. And so what you're going to do is you're going to take that and multiply it by 2. That'll tell you the length of the hypotenuse. So y is going to equal 22. And then from that short leg to get to the longer leg, you're going to multiply by square root 3. 11 times square root 3 is just written like this. 11 times square root 3. So there's my answer for y, and there's my answer for x.